Hey everyone, it's time for another session of Nurikabe World, and I'm excited for this one because last time we finished the tour portion of the campaign. We finished a bunch of different levels here, and we started variation. So here we've got medium to advanced levels, and we've got some variant rule sets as well. I'm interested to see what they'll come up with for variant rule sets. Let's just jump straight into it. I just saw variant pairs here when we left off last time, and I want to see what that has in store for us. Alright, pairs. Okay, numbers marked with 2 dots must be paired, sharing the same island. The island size is the sum of 2 numbers. Okay, I think I've seen this once, where we have sums. Let's see here. Okay. This one has to pair up with a 2 to make a size 3, but these two, this 2 and this 2, these are too far away, so this is the only way that works. Now this 2 and this 2 pair up, and those make a size 4 thing. It has to reach this spot here to not cause a pool. Loneliest number, okay, 1. Okay, these ones here, they cannot pair up with, they cannot pair up with each other because that makes an area that's too big. So this one, it has to connect to the 4 this way here. This one has to go out, the water goes out here as well. So yeah, they have to extend until they reach a number. That's also possibly going to be important. But yeah, I think I saw this in like this sort of variation. I think it might have been a tarot card themed set where different arcana had different themes, and this was lovers. So in lovers, they were paired up, basically. This 2 here has to connect to this 2, because if we go around this way, we have a size 5 thing. That's too much. So this 2 connects to this 2, and this 2 connects to this 2. And now we have 2 more spaces which are land, and those are in these spots to prevent pools from forming on the right side. Let's see here, connections. These ones can't connect. This one has to extend to connect to something, and it reaches this 4. If this one and this 4 connect to the center here, this one won't be able to reach anything, so the one connects to this 4, and this connection happens on the left. Partner. Okay. Oh, okay, we actually have a 1 here without any dots. I was about to like connect this to some other thing, but that's not gonna work. This one has to reach out to connect to a sum, but it doesn't connect to this 2 because this 2 is alone. These bits of water go out. This bit of 1 goes out here. That goes out to the 5, forming a 6 region. This 5 and this one, those are going to make a 6 region together, like so. Just gotta make sure all the water connects as well. Can't do connections in these spots because that connects 3 numbers to each other. Here as well. And this 4 can't connect to this 2 here. This 2 is alone. That's going to be annoying to check for if the numbers have 2 dots or not. This 4 goes out here. It's definitely going to connect to this 2, right? So this 2 can't connect to this 1. I actually think by reachability, like this 1 here can only connect to 2s which are this distance here away. Like 2s which are 2 away, 3s which are 3 away, 4s which are 4 away, that kind of thing. So this 2 is the only thing that can be reached by this 1. Water goes here to connect this bottom bit. And we have our 6 isolated down here. This bit of water connects at the top. This water on the left and the water on the right, I mean. this 3 here has to go to get this 2. I think it has to extend 2 to the left to make sure no pools form. And yeah, we're pretty much done. We just got to fill in the rest with water while avoiding pools. Dual. All right. Okay, this is neat. So we've got the numbers by themselves on the left side, and the numbers but with pairs on the right side. This one here can only connect to this 2. All other numbers are too far out of range. This 3 here has to connect to this 2. This 2 and this 3 can connect, but they can go down here, so I can't quite mark this yet. Okay, we just got to make sure that this water connects here, and now this 3 and the 2 have to reach up to prevent the pool. Actually, yeah, there's only one way we can do a 5 over here that prevents pools from forming, and now we've just got the solo numbers. And wow, it was actually easy for me to do the duo part rather than the solo part because we've done all these duo deductions just now. Extra, they can combine. All right, let's look at this here. Matchmaker. Okay. Well, we've got 1s and 2s. We can't connect 1s to 1s, so those separate. And that's how we get our first few matches here. This one connects to this 2. These ones have to separate, so we actually get some connections here. This one connects to this 2, and there we go. Pool patrol. Okay, there's a bunch of ones here which are just isolated. These spaces, we can't have pools forming there. I don't think water can go here. This would make all weird kinds of stuff here. So this is a 5 with these 2 connecting. This one is isolated. I think these 2s connect because this 2 can't reach any other numbers. So this 1 and this 3 have to connect, making a 4 region. Here we go. And yeah, this space has to be taken so that no pools form. And there we go. Just fill in all the water we can at the bottom. Not gamma. Not gamma. Why am I mispronouncing stuff here? We've got this 3 and this 1 isolated region. These 2s combine to make a 4. These 2s are going to combine to make a 4. That's going to flip-flop here. This 3 can only reach this 1 as a pair. And this 3 pairs up with this 1 up above. Just got to connect the water, and there we go. 4. Coin. We've got our slot in the middle thing going on again. These ones here can't connect. So this one goes out to this 4. This one's going to go out to this 5. This one, that means this one up here is going to pair up with this 3. This 3 here is alone. This 3 and this 2 pair up. So that's going to be a little bit tough to end, but you could, this 4-1, this 5 here flip-flops between these spaces, and this part can only reach 1 more, so all of this is unoccupied, giving us this. This bit of water needs to connect to the rest, now that there's a diagonal wall here. This bit of water needs to go out, giving us this 4. This bit of water needs to connect here. And now we just have to make this region here 6 large. Level 5, 2/3. We've got the 1 up top. Interestingly, I think if we connect these 2 3s, this here and this here, this 3 will be isolated. Same here, if we connect these 2 3s, right? This 3 is going to have to go around, and then it can't find another one to make a size 6 region. So these 3s sort of connect around this 3. This bit of water has to go out. This one as well. Now we just have to turn these all into size 6 regions. I sort of see it already, but I want to see if I can get it logically. The sill here is unreachable. I think if we have a connection like this or this here, that means this 3 has to connect to this 3, but we have to then need to place water cells in positions like these. This has to be water to make sure this bit of water here connects. And we just don't have enough space for the 6 if that pattern happens. So we actually resolve the bottom like so. Water has to go out. Okay, and there we go. That makes all these regions here 6s. I'll try to still keep my explanations logical, but we're going to get to this point where it's going to be hard for me to put stuff into words. That's kind of why I want to make these videos, so I can get better at articulating my thoughts. Anyways, this 2 here is going to connect to this 3. And then it takes one more cell here, and that has to be in this spot to prevent pools from forming. This 4 is by itself. This bit of water needs to go out so we have the 4 completed on top. This 5 needs to connect to another number and has to go around this 2. I'm thinking it connects to this 2 up here. So now we just have to make sure all the water flows properly. This bit of water up top has to connect to the rest through this spot. These 2s definitely connect here and then take one more cell. All this here is going to be unreachable, I think. This as well. This spot here needs to be filled in to prevent pools. This spot needs to be filled in to prevent pools. And we got it. We have to hug the wall on that side, which gave us the last bit reaching. Okay, we get a 3 hugging the wall. This 3 here is going to be by itself, separated from the other 2 things. We've got this 5. It wants to connect to something. I don't think we can connect these 4s to each other because then the 5 has to go over to reach something else. And then these 4s, this 8 region doesn't have enough room. So this connection happens. This is now a 9 and it's going to finish off like this. This 4 and this 2 connect to make a 6. These 2 will make a 6 as well. Switchboard? Okay, this is weird. We can't have water in this spot because that's isolated from the rest, so this one and this 2 connect. I think this 2 is the only number that's reachable for this one. We can't like go around here and reach a different number. That's just not going to have enough space. So the water goes out here as well. This 2 extends here, so this bit of water needs to go down. There's nothing in this area either. This 5 goes out. I don't think this 2 can connect to the 2 or the 5 here, so it has to connect to this 3. This 2 here has to connect to this 3 up top. And now we just have this 5 connecting to this 2. All this water has to go out though, so this 2 needs to loop around like so. And that is 7, so just fill in the rest with water. Flip-flops? Okay. We have a bunch of spaces where... Yeah, usually in cases like this we have different deductions, but We can only really put water in these spots where if we connect them, then 3 different pairs connect. This bit of water needs to connect to the rest, so we have this 4 region being isolated. This is rough because I want to do the diagonal separation so badly, but it can't. So all the regions here are going to be of size 4 because they're all going to be 2 plus 2. This 2 has to go down here. This bit of water goes out, meaning this region on the bottom left is complete. This bit of water has to connect to the rest of the grid through here. We have this 3 region, but this cell here is shaded, so it goes to the right. If we shade this cell, this 2 cannot reach another 2 in 4 moves, so these have to connect. These 2s have to connect, these 2s have to connect, these 2s have to connect. Because this 2 already reaches this spot, it only flip-flops between these. This 2 gets this cell here. These 2s have to reach one cell to the left to prevent pools. All of this is unreachable. This spot here is pool prevention, and there we go. Lopsided pairs, alright. Oh, that's interesting. So we've got, okay, first of all, 1's over here. And all of these pairs have a single and a double. So the single 4 is done. We have a double 4 and a double 5. I think the only number this double 3 can reach is the double 4, like so, through the center. And the double 5 needs to connect to the double 4. That is maximal, that is 9. These bits of water need to go out. 5 needs to go out one more here. And how do we complete this? This is gonna be wild. Okay, let's check for unreachable cells on the right. This 3 here is not going to be able to reach these. After the 3 and the 4 connect, they can only take up to 1 more cell. So this here is unreachable. That gives us the 3. 5 goes over here at least and takes 1 more. 4 can only reach up to these spots, so not here. Oh, this bit of water needs to connect to the rest, so we have this. That gives us our 4, that gives us this. This bit of water needs to connect here, and here. Gives us this pool. Oh, okay, this is 7, alright. I was a bit confused because I forgot to count this spot there. But yeah, we do have a 7 here. Okay, this is basically a Nurikabe with 4s. We have a bunch of 2s that are connected already, so we know how these are going to pair up immediately. These 2s will flip-flop between these spaces here, so this is definitely water, and it needs to connect to the rest up top. In general, this water needs to escape. So we've got that going over there. This bit of water needs to escape. Also, in general, we've got the 2s making an almost exact diagonal wall here, so this needs to go out. These 2s need 2 more spots without touching the other 2s. Now this bit of water needs to go out here to get to the rest of the grid. How do we continue here? We need this water to go down somehow. And actually... Okay, bear with me here. It needs to cross this grid line here, like between the 3rd and the 4th rows. So it either needs to take both of these cells or both of these cells, and this is the case that we're in. I don't think I've actually had to use a deduction like this before where it takes either 2 of one column or 2 of the other column, but we had to work that in here. This cell is unreachable, giving us a pool that we gotta fill in. And there we go. We end up looping around. Low V, okay. I do not know what they meant by this, but let's see here. This 5 needs to connect to a different pair, and it has to go down because it can't go up through these 5s. These bits of water need to extend, these 5s separate. This bit of water needs to go out as well. These 5s are separated from each other. Wow, okay, we end up creating a 10 region here just by sandwiching it between these 2 bits of water that need to go out. This 5 is complete. We've got a 1 and a 5 here. I think the 5 needs to touch this cell so that no pools form up top. This bit of water needs to extend to get to the rest. Now we just have a 10 region here. We have 12 spots on it, so we need to fill in 2 bits of water that don't form pools, while still keeping the 10 joined together. Alright, sunrise. Let's do this, and then let's see if we can hit the lines variant at the end here. This looks like it's not going to be a variant pack, it's just intermediate. So let's see how this is going to work. Have some unreachable cells in these positions, I guess. This spot here as well. So we actually have only one way where our 2 can go. Now this cell needs to be hit by the 4 to prevent a pool from forming here. This cell cannot be water, because then this pool is unpreventable. So this 3 definitely goes here. This cell has to be taken by this 3 has to take this cell. Now it can't take this cell anymore, and we resolve this 2. Nothing reaches here, and we get the 3 resolution. This bit of water needs to get to the rest, so we have this connecting to the 4. I don't think we can take this cell with the 3 because that creates a diagonal wall by forcing the 2 up. So that's how we get our 2, and that's how we get our 3. Dubious operators. Okay. We have a bunch of 1s filled in here. I don't know what the gimmick here is. I think the 4 needs to reach this space to prevent pools from forming in the top. Left. This bit of water needs to extend. Oh yeah, and now we have this pool here being threatened. So something needs to touch this. That is the 6. That is pretty tricky. Let's see here. This is sort of forming a pseudo-diagonal wall here, I guess, with if you include the holes. So the water needs to connect to this through this spot. This bit of water needs to go around the 8, so we have this go like this. And then we have this 5. We have the water needing to go around the 5. Roll for initiative. Okay, it's like a die. We've still got 1s, 2s, and 3s here. Fairly standard flowy deductions if you compare it to before. These bits of water are isolated. These ones near the hole here, I guess. This bit of water needs to go out. This spot here is unreachable now. Water escapes through here, giving us the 4 and this 2. We get the 4 and the 3 down below. Now we have some unreachable space here, I believe. Though this is not actually going to give us that much. We do know the 6 has to go to the left quite a bit. The spot here is unreachable. That has to be taken by the 3 to prevent pools. This 2 flip-flops here giving us this 3. This spot is unreachable, giving us this resolution for the top half. And now we just got to make sure that everything works out down here with the 6. This is weird. If the 6 connects up top, then the 2 is forced to the left, creating a wall. So the 6 needs to connect to this 2x2 here on the lower side, giving enough space to this 2. Alright, interesting resolution there. Lug. Okay, this is another stretched out grid here. This 6 has to go up above. This bit of water needs to escape, as does this 5. So we sort of end up creating this. This little pocket needs to be filled in by land. This 6 here goes out to this spot to prevent pooling. And now we actually have the entire right side sort of resolving itself. We get this wall here. We get this unreachable cell, forcing 2 pools that we have to prevent. I feel like there should be a better terminology for we need to place some water here to prevent a pool from forming. This 5 goes out here. The air is separated. This bit of water goes out here. I think if this 5 goes here, it's bad, because then we end up having to add these 2 cells to the 5 as well. And this, these 2 cells are water, but then this has to be land, which is bad. So we actually have to resolve the 5 this way, connect the water here. And yeah, that 5 gets solved like that. Okay, apparently there's an achievement for 10 animal theme levels, which is neat. Leitmotif. Alright. It seems to be another level with a lot of lower numbers. We can just get most of these here. This 3 goes up. I think we have some unreachable cells at the top here. This 5 can't reach this cell here, but most of the rest is no problem. This cell is definitely taken by this 3 or this 3. However, I'm going to argue that this 3 needs to go into this area to prevent pools from forming, so we have this actually. This 5 and this 4 are separated. They go out a little bit more. This 5 connects to these cells here. So we have unreachable cells in these spots. As well as here. Because this 5 can only go up 1, this 2 can only go up 1, this 5 can only go up to this spot. That gives us our 5. Our 4 needs to go over here to prevent this pool and this pool. Our 5 is going to have to go over here to prevent this 2x2 from pooling, and the final one is going to be in one of these spots. That resolves our 2 and our 3. Wait, whoops, I thought this was water, but it's not. Okay, we just have to connect this water here to the rest of the grid. And this happens like so. And now we just have to make sure that these bits of water connect while leaving only a 5 in the center. Which may be easier said than done. Oh, I see it. We bring it exactly like this. Cat. Okay. Another puzzle with just a lot of numbers. We get a bunch of ones that we can fill in immediately. This 2's on the border. Yeah. I think I'm sort of in a zone where I don't have to spell out every single one of these deductions. We do have to put this 3 over here to prevent it from blocking this other 3 in. These bits of water all have to connect, and that actually does give us our isolated 8. This 3 flip-flops, giving us this shaded cell as well as that shaded cell. This bit of water needs to connect to the rest. But yeah, since we are working with irregular grid shapes, we do need to account for all the water connecting. This 2 flip-flops between these spaces, this 4 goes out, this bit of water connects. This cell here has to be land, and the only number it can connect to is this 4. This 3 was given by this 2, actually. This is water. This cannot be land because if it is, it connects to the 3, and that blocks in the water here. So this is water as well. This is land. We have a bunch of unreachable cells in these positions, giving us the 2's. This cell has to be water to land to prevent pools from forming. And there we have our 3's. Alright, this one was a bit grindy, but it was cute. Warning? Okay. More fairly small number deductions, a lot of them though. So let's see where this heads. Okay, this bit of water needs to connect to the rest, but it can't take this cell here because that blocks it in by creating pool. This cell here is unreachable, giving us the true resolution. These flip-flop, both of them. This cell here is unreachable, giving us a lot of pool deductions. Similar here, we had an unreachable cell in this spot, giving us the way how the 3 went. There we go. This bit of water needs to connect to the rest of the grid over here. Yeah, this 2 and the 3 separate. We have this bit of water going out. I guess we have unreachable cells in this spot. That creates a pool deduction. And there we go. Alright. Glued squares. Let's see here. This seems a little bit more interesting with the the narrow gap there. I'm thinking this might sort of involve an earlier deduction that I showed where we have to bridge the water between the left and the right sides, and we do that either with these or with these. Now this bit here has to be land, because if it's water, then we have a pool. That needs to connect to the 8, and in order to do so, it needs to wall hug. That gives us our 8. That means this is all water. This spot here needs to connect to this 8. And a... Okay, if this here is land, it has to connect to the 4 or the 8, which... Like, if this 4 connection happens, it fences in the 8, and if this 8 connection happens, it fences in the water, which both of those are bad. Let's see here. This 8 can only reach up to this spot as well as this 4. So this is unreachable, these are unreachable as well. This 4 has to go up to this spot at least. This spot is taken by either the 8 or the 4. It's weird, I don't see the immediate way to resolve this. Okay, this cell is now unreachable by both the 3 and the 4. I do believe if this cell here connects to the 8, we can only have 3 cells around the 4 that work. So it's going to restrict the 4 by too much. That means this 4 goes up to this cell here. And the only way to do that without restricting the 8 is by extending fully towards the right side. And there we go. That was actually tough to figure out. This 3 here flip-flops. This 4 has to still let the water through, which is why it takes everything on the left side. Now we have an unreachable cell here. These cells are separated. This bit of water needs to go out. We have a whole bunch of cells here that are isolated. These cells can't be reached, giving us another pool. And let's see. Yeah, we've got this 2 and the 5. This cell here has to be land. The only number it can connect to is this 5 up top. But that restricts the numbers this 5 can reach up here, as well as all of these 2s. This spot here has to be taken by the 4, but then it can either go up or to the right. None of these numbers here get taken by the 2s, which give a lot of pools. This spot here is not reached by the 4. Goes over here. And now this 3 flip-flops between these spaces, so this is water. This spot is unreachable. This spot here has to be filled, so we don't have a pool. And now, yep, the 3s resolve. This spot has to be water. Oh yeah, if the 4 resolves this way, we sort of have isolated water over here. Now that this 4 takes both of these, it flip-flops between these 2, so this is definitely water. And what's next? The 4 does not reach this space because it needs to have something in this 2 here. Or rather, if this cell here is water, then this cell here can't be reached, forming a pool, so this is definitely land. This 4 takes one of these 2, so this is definitely water. This cell is unreachable, giving us this 3. That gives us this 4 as well from the pool. Damn, that's a lot of deductions. Okay, clover. Let's see here. Got a lot of 4s and 1s. This 4 flip-flops over here, so this has to be water. This 4 goes up. This bit of water needs to escape here, so that 4 is done. This 4 definitely needs to touch this spot here to prevent the pool from forming there. This bit of water needs to connect to the rest of the water. This 4 goes out. can't go over here because that restricts the area of this 4 to 3. This bit of water needs to connect to the rest, so we've got that. There we go, just connecting the bottom left water. This area here needs to connect to the rest of the grid through up here. These 4s are separated. This area up top needs to be... This 4 needs to extend to the right so it doesn't... it prevents pools. This bit of water needs to connect to the rest of the grid, so this 4 has to stay on the right side. We get this L. This bit of water needs to connect. This cell needs to be land, so it connects to this 4. This cell here has to be land, so we don't have a pool. Alright, we are flip-flopping between these 2 spaces as well as these 2 spaces for the 4s. This 4 takes this spot. This bit of water needs to connect. We do have to connect this bit of water here to the rest, and there's only one way that that can happen. And now for the rest here. This bit of water on the top right needs to connect like so, and that gives us the rest. Okay, that is 3. Okay, let's just... I think we can still check out the lines variant here. Let's do that here, and then let's see how it applies in the next. Okay, numbers with the line must have the shape of a straight line. Okay, so they're 1 by X rectangles. That means this 4 has to go down here. This 3 has to go like so to prevent pools forming. Thinking flaps. Okay, this 3 has to go up. This 3 can go up or to the right. Either way, the cell here is definitely water. That means this 3 can't be horizontal, it's got to be vertical. But that does mean if this 3 goes up, then nothing can go here. So this 3 has to actually go down. That is an interesting way of thinking about things. This water needs to connect. This 9 needs to make sure no pools happen, and there we go. Missing hints. Okay. So we know this 4 has to go up or down. And it has to go up to let this water connect to the rest of the grid. Okay, essentially I think we have this here, but like the water going here, so this 4 goes up, this 3 goes down. Logically, I would explain it as the 4 needs to hit this spot to make sure that we don't have a pool forming over here. So that needs to go like so. This bit of water needs to connect to this rest of the water down below here. And at least take one cell over here to separate the 4 and the 3. Now the 3 needs to go down here, 1 to prevent a pool, which means this is water going down. Okay, balanced, try it. We just got a lot of 3s. This one here can't go horizontally, so it is vertically. Okay, consider if this 3 goes horizontally, it's going to create a pool like so. This is actually going to be vertical. None of these cells here can be reached anymore, so this 3 slides over to the right. This spot needs to be filled in by something to prevent pools from happening, so that is our 3 resolution there. We get this 3, this goes down, and there we have it. That is weird to keep in mind as well, that we still have to make sure that no pools happen. Unfounded, I think that was called. This 4 here cannot go horizontal because that blocks in this 3, so it does go vertical. This cell here is land, it connects to the 4. This 2 flip-flops here, but this is definitely unreachable by the 2. So we get this little thing happening over here. This 3 either goes... Oh, if this 3 goes up, then a pool is created. So this 3 goes to the right. This bit is connected to the 4. This 4 goes up. Now these cells are all unreachable. This 4 goes up to prevent pools. These cells are unreachable here. This 2 goes to the right to prevent a pool. And there we have it. It's another one where it's like, oh hey, these 4s don't actually have a line, but we have to make them into lines because of how the grid is. Mind the flap. Okay. This 3 can't go horizontal because that traps some water in this spot here, so it goes down. This 4 goes down here as well. This 3 can't go up now because that creates an isolated region of water on the right side. So the 3 is horizontal, and that gives us the rest. Underscored. I read that wrong. I thought it was like scored too low or something, but it's just the word. Ignore me. We've got this 3. It needs to go 1 to the right to make sure this water doesn't form a pool. This bit down here, this water has to connect through this gap as well as through this gap to reach the rest of the grid. This water needs to escape as well. We need... okay, these cells here are unreachable and we need this 3 to go to the left to hit these cells. This water goes up. This water goes around the 3 here and around the 3 here. All of these cells are unreachable by the straight lines. And there we have it. Packing. Okay. Let's see here. This 3 can only go to the left. We have a weird unreachable cell situation here up top, where this cell can only be reached by this 5 or this 5, and actually this 5 can only go up because of this 3. Now this 5 can't go down, so it goes across. This cell here has to be taken, it gets taken by this 3. This cell has to be taken, it gets taken by this 3. And so on and so forth. We just need to make sure that the cells, if there's a corner, then the last cell gets taken by another thing. This 4 and this 3, they both have to go up. The 7 goes down here. If this 4 goes up, then a whole bunch of pools happen here, so that's bad. The 4 goes down. I mean, it goes across. This cell over here can't connect to the 4, needs to connect to the 7. That means this 4 goes down here. And there we have that. Flip-flops double question mark. Why double question mark? I'm scared. Anyways, the 3 goes out like so. This 3 either goes this way or this way. Either way, this same flip-flop deduction actually does happen. Oh, one cool thing here is that for these 2 3s, they either go like so or like so. Either way, this is definitely land and this is definitely water. This 3 only has one way it solves. This 3 goes up. This bit here is water with this bit being land. This water goes across here. This bit is water, meaning this 3 has to make sure that no pools form here. This 3 extends to this spot. This bit of water needs to connect here. And that goes all the way around. Now this cell here's water. This 3 only has 1 resolution. This bit of water needs to connect to the rest of the grid, so that resolves these 3s. This 3 goes up, this 3 goes like so. And damn, that is 200 levels. I want to start on another thing here, but it's been 50 minutes, so I think I'm going to call it for this episode and look at the rest in the next video. So thanks for watching, and I'll see you then. Hope you're having fun so far, puzzling along with me. Bye bye!